So again, in a perfect world, you'd be able to take y is greater than x squared minus 2x plus 3, find the axis of symmetry, plug that in to get the vertex, find the y-intercept, graph that, reflect it, and draw in your parabola. But to save time, I dotted that parabola in for you. So really, all we have to do is look at this symbol and decide, should this parabola have a solid curve or a dashed curve? It should be dashed. Remember that greater than symbols and less than symbols, if they don't have the equal to line, it's a dashed line. And so you might think, oh, hey, the graph's done. It's already dashed. Well, I dotted it in for you, but take the time to at least draw in a dashed line so I know that you have thought about that this needs to be a dashed line. Once you've drawn in your dashed line, think about, should this curve be shaded up or shaded down? It's a greater than symbol. Greater than means shade up. For greater than or for greater than or equal to symbols, we shade up. Now, what does up mean? Think about what is above this graph. So that, in this certain case, would be inside the parabola. I don't want you to think inside versus outside. I still want you to think up versus down, because sometimes up will mean the outside of the parabola. If this parabola had been upside down, then shading up would have been shading around the parabola. So still think of it as shading up or shading down, and just think about where that would be. If necessary, put your pencil on the vertex and draw an arrow straight up. Whichever side of the vertex that's on, shade that area. Number 2, try that one on your own. Think about solid or dashed line, shade up or shade down. This will be a solid curve. So connect the dots, la la la, connect the dots. And this time we shade down. Less than and less than or equal to, we shade down. And in this case, shading down is the outside of this parabola. It's going to kind of be split into 2 pieces based on where our parabola is located. Now, I do want to take a moment to make sure that we've reviewed what the point of graphing inequalities is. We are visually representing all of the possible solutions for this inequality. So if we go back to number 1, and I put a point right there, point A. Is point A a solution to the inequality in number 1? No, it's not in the shaded region. Is point B a solution? Yes. How about point C? Point C is not a solution because it is on a dashed line. However, in number 2, if I were to put a point on the line and call that point D is a solution because it's on a solid line. If a point is on a solid line, it is a solution. If it's on a dashed line, it is not a solution. So, number 3. What's different about number 3? There's 2 graphs in the same coordinate plane. This is where you need to use everything that you know about parabolas to figure out which parabola goes with which inequality. So the first parabola, there's a couple things that you can notice. The first thing is this isn't really noticeable, but this is standard form. Your b value is just 0. So -4 would be our y-intercept. So this first parabola has a y-intercept at -4. But the easier way to recognize, do you see a negative in front of the x squared? No, it's a positive x squared. That means this parabola is going to open upward. So the parabola that's opening upward is our first parabola. Should this one have a solid or a dashed line? Solid. And should we shade up or down? Greater than? Bigger? Shade up. So our right side up parabola is going to have a solid line. And when you shade this, try not to shade this too darkly because we do have to deal with the other parabola. So I'm just going to do some light blue lines in here. Our next parabola, notice there's a negative in front of the parentheses. That means that parabola opens downward. Should this one be solid or dashed? Dashed. And should we shade up or down? So this one, dashed. Take the time to actually dash it in so I know that you've thought about it. And yes, on the test for this one, I will have it dotted in for you, and you'll just have to fill it in solid or dashed and then shade the appropriate area. For this one, shading down, that would be inside underneath this parabola. Okay, the final solution is the place where the shading overlaps. Where does the shading overlap? Inside this little egg shape. When you have two parabolas, they won't always overlap inside the egg shape where they overlap. They might overlap in this bottom area. If the blue one had been shaded down and the green one had also been shaded down, then we'd have like a little volcano with a crater on the top. We would have this area down here double shaded. But since one of them was greater than, the other was less than, they overlap in the middle. Okay, number 4, I noticed that there's 2 inequalities, but there's only one thing on the graph. So, do you see how this first inequality has a square in it? That's our parabola. How would you describe this other inequality? It's just a line. Do you remember how to graph y equals mx plus b? Start on the y-axis, use your slope. So try this one on your own. Start with the parabola, decide solid or dashed, shade up or shade down, then graph your line, solid or dashed, shade up or shade down. Okay, this parabola should be a solid line because it's less than or equal to. And I made a little chart in the middle that might help some of you who struggle with that a little bit. And this is going to be shaded down, which is going to be this area all over here, which is a very, very large area. Then for our line, we're going to start at 4 on the y-axis. A slope of -2/3 means down to right 3. Down to right 3. This one needs to be a dashed line. And it needs to be shaded up because it's greater than. Okay, this double shading is honestly kind of difficult to see because you end up having almost the entire thing shaded. So it is really helpful if you're having trouble with this. You might want to try using colored pencils and lightly shade with one color, lightly shade with a second color, and then look for where those colors overlap. The overlapping is this wedge on the left and this piece on the right. If you shade lightly with pencil, when you're done shading both, shade the final area extra dark, or at least significantly darker than the rest. You can also take an eraser and erase out the shadings that aren't part of the final solution, and that'll make your graph, your final graph, look better. Or if you want to grab a highlighter and highlight your final solution, or if you want to use 2 colors of highlighter and then write down, like I've had people use yellow and green. So if you use yellow and blue, and you put them together, the final solution is in green. So then you could put a little note next to the side that says, this is my solution, so I know what the solution area looks like. So try to make it obvious for whoever's looking at your paper where the final solution is.